Hello, everyone. We are Beyond, a Sky Catalog website built to provide information about space in an interactive way. Our team consists of me, Alessandro, Rita, Fermi, Shantae, Isaac, Thomas, and Carson. Here is a sneak peek into what we will be sharing with you today.
So, our objectives, the purpose of our design was to provide users with information regarding space, such as stars, planets, nebulae, galaxies, and etc. And users are also going to be able to browse through a 2D map of space and select celestial objects to get information about each one. And they'll also be able to look up groups of objects based off of the date, the constellation, the magnitude, and they'll also be able to add newly discovered sky objects to the database. And they'll also be able to favorite celestial objects for later viewing, linked to their accounts. An important goal we wanted to achieve with this was the improvement of accessibility of information related to astronomy. And we believe that making the information accessible can satisfy people who are already interested in astronomy, and it could also potentially spark curiosity in others as well. And this was achieved through the completion of our other goals, like creating a seamless interface and ensuring our application is scalable. And
we'll now go into our requirements. We have various requirements such as user and account management, Sky object pages, favorites, and layouts. We will first log in with our test email, and we get to our landing page, which has various information about our website. We'll now go through Sky objects. As you can see that various Sky objects were returned. We can select an object and to see its info. We can also find stars with our Sky map by simply pressing one of these stars and going to its object page. As you can see, it also displayed the info. We can also favorite many stars that we like. Let's do that real quick. And our favorites go across. We can then add and reset these to our liking. We can also create a star object with various fields such as name, type, magnitude, and many others. And we can also edit our profile. We can also edit our profile picture URL and username, and we can also delete an account if we have to. And as you can see, the profile updated, and we can log out. I'll go through our register requirements, where we can fill in these fields.
This one? Yeah. Editing fire team. Did you go to videos? Mega Halo.
And as you can see, it successfully registers. We can also sign in with our Google account, with the Google OAuth. As you can see, it's successfully logged in. We can also use guests where we don't have to log in. However, you cannot favorite and add objects.
I will now demo that Sky objects can be queried based on multiple fields such as NGC. For example, we'll do 6633. As you can see, it successfully searched for 6633. You can also search based on minimum and maximum magnitude, so we'll do 1 and 5. As you can see, the magnitudes are only between 1 and 5. And we can also search by constellation that a star belongs to, and these constellations are all from Ver.
For non-functional requirements, we went over the ideas presented here. For security, we hash passwords so that it's never presented over the network as a string for what the password actually is. For usability, availability, reliability, performance, and scalability, we used AWS's Lambda functions and cloud computing in order to scale easily, reliably, and availably. Maintainability, we used GitHub as our source control, so then we could easily make changes to the code, and we used Netlify's CI/CD pipeline in order to quickly deploy changes that we made.
We used an RTM to keep track of the implementation and testing status of each functionality. It proved to be very valuable in compartmentalizing and organizing our development. I'll now show it. As you can see, our RTM is set up really intuitive. Within each requirement, the completion status and testing status of each requirement is also listed. As we developed our application, we regularly updated our RTM to ensure each group member was on the same page and what had to be done. So we have various requirements such as user and account management with all the functionalities of that, Sky object pages with all the functionalities of that. As you can see, there's tests for each, and favorites and layout also.
Our application's architecture is service-based MVC. MVC architecture was selected for its simplicity and for having clear separation between components. This separation of components allows us to easily distribute work between team members. The service-based architecture style was used in our model component to allow for future scalability as needed. Also, the separation of services ensures a high level of modularity and testability of the modular component. So as you can see in our figure here, within our application, users interact with the MVC view component, which consists of several website pages. User inputs in the view are then handled by the controller component, which contains controllers for different functionality. The controller also interacts with the model component, which is composed of several services. These services contain AWS Lambda functions, which interact with one of our two DynamoDB databases.
So now we're going to get into the main design of our project. So first up, we have a use case diagram. This was our initial use case diagram for our system. The goal was to have 3 different types of users, admin being an optional one, that can browse Sky objects, create Sky objects, and favorite Sky objects to their collection. We also thought of potentially adding a friend system, which in the end we decided not to, and the notification system was also a potential addition as well, which we didn't end up adding.
So the next slide shows our ER diagram, which is an initial idea of how we were going to construct our database. It essentially just has 2 main tables, the user and the Sky object table. There's 2 types of users that we initially planned to have, which were admin and registered users, and this just shows how each of them interacts with the Sky objects.
So now I'm just going to talk about the sequence diagrams that we made. So these kind of just showcase the flow of events for a few different scenarios. So we have one for login, so this just showcases the flow of events for a user logging in. We have a sequence diagram for a user registering into the system, so they're just entering all their credentials and how it interacts with the different objects or database and whatnot. We have a favorite sequence diagram, a guest sequence diagram, and we have a create Sky object sequence diagram. And these kind of all just show flow of events for different scenarios on our website.
So we'll now show how we tested our system. The front end was achieved with Selenium and the back end was achieved with Postman. Our Selenium tests each test a requirement in the RTM.
So this is Postman, which is a service we use to test our backend functions. All of the functions are encapsulated within each of these 3 sections, which are user tests, favorite tests, and object tests. This test script can also all be ran automatically, which is a nice thing about Postman. It's part of the reason that we chose to use it.
For our next steps, we're planning to implement admin features, add more functionality to the Sky map, and add about/contact pages. Looking back, we think we did a really good job splitting up our tasks, meeting deadlines, and communicating with each other.